In most hospitals, the chief cardiology surgeon spends the day in the operating room. So in the ICU, junior doctors and nurses are stuck waiting for the senior, even on simple procedures. Patients wait. Care is delayed. So we built an agent that reads the patient's imaging in labs and drafts a preliminary diagnosis before the junior needs to call the senior. Watch this. This is the nurse intake. The nurse types the patient's state and vitals, then uploads 4 cardiac images: ECG, chest X-ray, echo, and CT. In production, this would pull from the hospital EMR. For version 1, we kept it manual to keep the demo clean. I hit Start Agent. Behind the scenes, the request goes to Qwen 2.5 vision language, running on an AMD MI300 GPU through VLLM. The model reads the images, the labs, the patient's history, the vitals trend over the last 6 hours, everything together, and drafts a structured preliminary diagnosis.
In seconds, the agent processes the images and history and outputs a clear diagnosis: an anterior wall STEMI. It flags this case as simple, meaning the junior doctor can manage it. With the recommended actions and evidence clearly listed right there, the junior can start treatment immediately without waiting for the surgeon. But the real power is the continuous learning loop. The senior doctor doesn't just read the output, they can edit it. Watch here as I add a specific custom correction to the diagnosis. When I hit Approve and Save, this doesn't just update the patient record. It feeds directly into our RAG system. Every edit and piece of doctor feedback is instantly stored. The next time a similar case comes in, the agent retrieves this exact correction, meaning the system continuously learns from the hospital's best doctors. Here is the complex flow. By feeding the agent deeper inputs like an echo and CT scan, it analyzes the full clinical picture. Watch the output. It immediately flags this as complex. The system knows this is beyond the junior doctor's scope, so it halts the simple workflow and instantly pages the senior surgeon with the full analysis.
Here's the bigger picture. Hospitals can't send patient data to the public cloud. EU regulations, hospital-grade privacy, patients' lives on the record. They need everything to run inside their walls. So we built on a stack that goes anywhere. Qwen 2.5 vision language is open source. VLLM is open source. AMD MI300 is hardware they can buy and put in their data center. Today, our demo runs on AMD's developer cloud. Tomorrow, it's the same code, the same model, the same GPU, just sitting in the hospital's basement instead of a data center somewhere else. No vendor lock-in, no cloud dependency. This version handles cardiology. The same architecture extends to pulmonology, neurology, and the rest of the ICU. Each specialty gets its own pool of senior corrections. The senior surgeon stays in surgery. The junior doctor gets an instant draft. The patient gets care without waiting. That's the cardio agent. OpenStack, portable, ready for